All right, ladies and gentlemen, here we go. Chapter 5, Lesson 7, Subtracting Linear Expressions. Before we had done addition of linear expressions, so now we just got a little tweak to make when we're subtracting them. As we look forward, we're going to do a quick little bit of review. I just need you to listen on this part. When we see 2x plus 4 plus 3x plus 2, we got those in terms of actual pictures and what those represent. Here I have my two x's. Those are unknown values, no idea what the identity of those, and I'm adding four things with a very specific identity to those two x's. Can't mash them together because I have no idea what those x's stand for, so I can't add four things to something I have no idea what they mean. So when I take this quantity, 2x plus 4, this is the picture that it represents. When I add it to 3x plus 2, I'm adding it to this picture. 3x's, three groups of x, plus two individual identities. So now I have this expression of 2x plus 4 plus 3x plus 2. What that translates to is I'm going to get my answer as 5x, 1, 2, 3, 4, 5, plus 6, 1, 2, 3, 4, 5, 6. Really, I just started to mash these things together. I added my 2x plus my 3x to get 5x. And I added my 4 and my 2 to get 6. So as we can, this is just a good pictorial breakdown as to what we're doing and why you can add like terms and why you can't add unlike terms. I can't add 5x plus 6 to get 11x because I have 6 things adding to 5 different groups of an unknown number. They can't be added together. So my final answer would be 5x plus 6. So this is a quick recap of where we came from before. Review over our four rules because those are going to be the exact same except we're going to have some tweaks for sure. So I'm going to have you write these down again. Take a pause if you need to. I know you've written down before, but they're going to help you with your subtraction. I did put an asterisk next to turn subtraction to addition, so that one's going to be super important. Then I want you to write distribute if necessary, except it's not going to be necessary here. So write necessary, but then make sure you cross it out because it was if necessary when we were adding. We need to distribute for sure if we're subtracting linear expressions. Then when we're all there, then we just got to shape out our like terms again and then add our common shapes, and then we'll be ready to move forward. Go ahead and click pause if you need to write these down. Otherwise, click play when you're ready to move forward. To kind of put those into play, we're going to kind of take a peek at where we were before and where we're moving next. So this is just listening. Before we're adding two linear expressions. Remember, this is one linear expression, 3x plus 3. 4x minus 2 is another linear expression. We were adding those together. Now, in this new session, we're taking that exact same linear expression, except we're going to subtract it from the other linear expression. So that's our big difference, is now we have a subtraction sign between my two linear expressions. Okay? So just subtraction sign. That's our big difference. As we tackle it, I wanted a reminder of what the multiplicative identity tells us. So go ahead and write this stuff down. Get this example written down and write this number chain next to it. We have x plus 3 minus x plus 4, and the multiplicative identity says I can put a 1 in front of both of those, and 1 times x plus 3 is just x plus 3. 1 times x plus 4 is just x plus 4. So when I write these down, that means the exact same thing as 1 times x plus 3 and 1 times x plus 4. That's going to be super important when we start to subtract, to make sure that you know there's a 1 in front of those. So jot those down and just remind yourself of that multiplicative identity. So when we said turn subtraction into addition and distribute, those were some tweaks that we're going to do when we're subtracting linear expressions. When I turn subtraction to addition, I know that I'm going to have I need to turn my addition sign to, my subtraction sign to addition, then make the second number opposite. So now I have 1 times x plus 3 plus negative 1 times x plus 4. So when I'm adding, now I need to distribute because now I have this negative sign, negative 1, and that actually changes what x plus 4 is going to be. So if I take negative 1 times x, I'm going to get negative x. And if I take negative 1 times 4, I'm going to get negative 4. So now when I rewrite, I have 1 times x plus 3, or just x plus 3, because 1 times x plus 3 is the exact same thing, plus negative x plus negative 4. I distributed my negative 1 to both the x and the 4 to make them negative. When I multiply by negative 1, the numbers still stay the same, x and 4, except I just make them negative, because a bad thing happening to a good person is bad. It turns it negative. So this big thing with subtracting is we must distribute that negative to both parts of our linear expression. So whenever you turn this subtraction sign here to addition, make sure that both parts of your next linear expression become negative. And so now when I'm adding them together, now I have my linear expression. Now I can start shaping stuff out. I have my x's, and then I have my constants and constants. I would add these together. to get negative or positive x plus negative x is 0 x's, and 3 plus negative 4 is negative 1. This gets simplified to negative 1 plus 0x, but I don't need that because 0x does nothing for me. So the big thing is distribute that negative sign from your 1 to both the x and the 4, or whatever your two terms are in your linear expression. We're going to go through a quick example about how to do these. So first we need to turn all subtraction to addition. The only thing that I have is this subtraction sign, and so that's going to make it a negative linear expression. Now I got to distribute that negative to both parts. The negative of a negative is a positive, and a positive 5 turns into a negative 5. So as I rewrite, I have 2x plus 4 plus x plus negative 5. And now as I shape out and I figure all my stuff out, shape out my x's and shape out my constants, and now I just add them together. 2x plus x is 3x plus 4 plus negative 5 is negative 1. So my final answer for this linear expression is 3x plus negative 1. Very quick video, but the big thing you got to know is that when you're subtracting between, you got to distribute that negative to both, and then we carry out exactly like we have before. To get into our joke of the day, why did the stadium get so hot after the game? I've done this answer because all the fans left. All the fans left. Got really hot after the game. So make sure you distribute that subtraction sign to both terms. Sayonara, onto your bookwork. Best of luck.